Hi everyone, my name is Jesse Noller. Without going into too much background, because as you can see on my screen, which by the way, this is my first screencast, so just be kind. I don't know how to edit, don't know how to do anything. All right, up on your screen, you'll see, or up on my screen, you'll see a link to my repo called Kubernetes, where I go into, if you go into the docs section, you will see a very long write-up that is still ongoing regarding the issue that I'm showing, the background, how to trigger it, and eventually how to completely diagnose, debug, and isolate. What I'm going to demonstrate to you is a container runtime failure, or specifically node failure, that is triggered when you execute a helm install istio command. Now, the important thing here is, as you're seeing up on your screen, there is an issue. The issue here is that we have a cluster. The cluster that I'm about to use is 5 nodes. These map to an Azure DS3 v2 SKU. This machine has a very large number of IOPS, or file operations per second, 12,800. Meanwhile, we have an operating system disk attached that is network attached storage that has a maximum IOPS quota of 500. This is a bit of a unintuitive problem, so I encourage you to kind of read what I've written and ask questions. Without going too much further, a real quick setup. You can see here, KGNO. This is my 5-node cluster. Everything is good to go. I've actually just rebooted these, made them all nice. In the background, I also have the Prometheus operator and a bunch of other tools going. I also have active ongoing SSH sessions to all 5 nodes. Each terminal window is actually in sync with the other. Thank you, iTerm 2. Here, you can see that I've got multiple windows open, and I'll show you why in a second. Same thing here. Here, you can see that I've got some other debug windows. This is the output of a DNS debugging pod that I have running in the background. This is a little script that locally just watches the state of the cluster. Just says, give me the output wide, and then describe the nodes. Pretty simple. This is my background task for connecting to the dashboard, and this is my working terminal. Here, over here on the cluster, as you can see in the background, right here, I have a bunch of debugging tools, and I've documented these already. These are from the IOPS project. Then these use BPF underneath the covers at the kernel level to extract really important critical performance and data metrics from everything. I've got these running in the background because I know what I'm about to do is going to hurt things, and I like to get the data. As you can see here, over on this terminal, I've got some background processes going. Everything's good to go. Without further ado, I'm actually just going to copy and paste this command into all of those terminals. What this is going to do is this is going to give us a nice running log from the file system. This log will actually tell us around any process or function, specifically process, that has a longer than 1 millisecond disk latency time. So here you can see that in a steady state, the relative disk latency for your ongoing operations, and yes, this cluster is idle except for the Prometheus operator, which if I go over to here, you can see right here. So in a normal running situation with just normal container load, you can see that your average latency isn't that high. But you can see that there was a bit of a blip here. All of a sudden we saw biotop suddenly spike on node 3. I want to go, and at this point we have a steady state cluster. Everything's up and running. kgpo - all namespaces. Live demos. Everything seems to be running. Got a couple of pod restarts. What the hell? So if I say istio ctl, this is just the command in my buffer that I've already run. So in theory, it should work. So as you can see, istio.ctl is actually applying the manifest and starting to kick everything off. In this window, you can start to see that there is a pretty strong correlation to work execution and deployment to immediate latency spikes. Now, you can see here, nodes where work is getting scheduled the most start seeing latency spikes higher and higher. In this case, we can see that there are some latency spikes upwards of 1,000 milliseconds, hundreds of milliseconds, so on and so forth. These are affecting all of the processes running on the system. Kubernetes, Docker, etc. See, this is happening to every one of those nodes. Here, everything says it completed successfully. Let's actually go and look at the pods. You can see all of a sudden our restart count has started to climb. Here, you can see the logs from DNS. This is a DNS debug pod. Here you can see your average return time for DNS in milliseconds. Here you can see kubedns, 0 milliseconds. Everything seems very fast from the pod. However, if you keep watching this in a loop, what you'll start seeing is you'll see high variance in the DNS queries going from pod to pod. And this is because, as you can see, every one of these nodes is completely saturated. We're seeing file system latency higher and higher and higher. You're going to start seeing more and more variance in things like DNS that run in pods within the cluster. In fact, you can actually see this DNS kube get nodes wide. We'll say kg k top node. You see the memory usage, CPU usage, isn't completely out of bounds, but you can still see we're getting a lot of pings on the latency over here. So I've already shown that we can inject high amounts of latency because of the throttle that's happening at the operating system disk layer. So here we're looking at the logs. And over here on the left-hand side, we've got a view into ext4 slower. Now work is still being scheduled. Here you can see node 0 over here on the right and node 0 over here on the right. You can still see that there are disk latency spikes occurring, but there are fewer and fewer. That's because the work is starting to actually quiesce. But here you can see an example of the containers themselves still being orphaned. This means that all of the nodes are still thrashing. Here you can see that from the perspective of the kubelet, there have been lots of failures across everything in the terms of runtime. Sync loop plagues, there have been orphaned containers, a lot of other things are going wrong. The metrics that we have available, here you can see the use metric of a single node. But let's go ahead and look at the cluster. You can see that CPU utilization went up, obviously around 1600. That's when we kicked off the test. Everything kind of spikes up, that's great. But then here, right here, if we line these up, you can see CPU saturation spiked when we kicked off the test. That makes sense, work is getting scheduled, and you can see that everything keeps chugging away. You can see memory saturation doesn't really come into play. You can see a whole bunch of network stuff. That's because of the Docker polls, everything else. But here is the key. If I zoom in on this, it shows is that from the time that work starts to get scheduled, etc., what you start seeing is you see that CPU utilization go up. You see the disk I/O utilization go up. Now, this is why you miss this in most cases. You're looking at disk I/O utilization. You're looking at other metrics. Here is the Kubernetes use metric for disk I/O saturation. Now here, I've actually jumped to the kubelet report. This is super critical to understand what's happening here. For all of these logs that you see here, you're seeing full lifecycle events just failing. This means the containers are gone. They're being orphaned, your memory is increasing, things are going wrong. If the load does not back off, eventually the node will begin to completely fail. This means Linux will eventually panic in certain scenarios, especially if you're using external file mounts. What really happened from the perspective of the kubelet on every one of these worker nodes? You wouldn't see this from the perspective of a service, etc., because this is all happening on your worker node. Here you can see as soon as we kicked off the istio deployment and all of that work started to get scheduled and all the pods started to go out, pull image started to get extremely highly latent, create container started to have severe issues, 2.47 seconds to run pod sandbox is pretty terrible. And then you can see throughout the entire system, health checks, pod start rate, everything. You can see within the logs what is happening. There's just thrashing. Additionally, if you keep going down, there'll be more and more errors around orphaned PVCs. And as we deployed istio, the other pods restarted. So these were all the Prometheus pods. If this were my workload, this would have been my customers losing access to their application because of the deployment of istio. This happens with other deployments, and this happens with deployments all of the time. It's a common misconfiguration. So finally, I'll leave you with this, because I'd actually like to get off this and go work on documenting everything and pulling apart all of these logs. So as you can see, at around 1600, CPU usage went up, and it gained a pretty consistent rate. Memory usage also went up. Now, if I were to leave this running as is, what you would see is that memory usage would start to go up over time. And this is because of these ongoing failures inside of the logs. Anyway, I encourage you to take a look, learn a little bit more, ask me some questions. I just effectively killed a running workload.